Okay, what I have here for you is a little surprise. You might not recognize this. This is your book. Um, there's pictures and problem numbers and answers and everything. But in case you do recognize it, I'm going to go ahead and go through one of the assignment problems. So you are supposed to be maximizing volume of this package. And we talked about it in one of the classes, but didn't get all the way finished. So you have a constraint here. And the constraint is what you're going to use to substitute. The constraint is if you combine the length and girth of a box. So that has to equal 108. Well, the girth is the perimeter, so that's 4x. And the length is y. The most that can be is 108. So that's your constraint. That's like our piece of paper that we're cutting. So y equals 108 minus 4x. And then we are trying to find the dimensions of the package of the maximum volume. So we're maximizing volume. So write a formula for volume of this box would be x times y times x. So x squared y. So this is what we are finding the derivative of. So you can substitute now. Volume equals x squared times 108 minus 4x. So that's 108 x squared minus 4x to the third is our volume equation. So you can start plugging in and guessing there like we did initially, but we're not doing that now. We have derivatives. 216x minus 12x squared. Set it equal to 0. So you can factor out, solve however you want to do that. You know that one of the solutions is 0, but you can't have a box that has a dimension of 0. You can factor out 12x. Leaves you with 18x minus x. Sorry, leaves you with 18 minus x. So x equals 0 and 18. If you're not sure if that's a max, you could test it. You could say from something from 0 to 18 and something from 18 to infinity and plug it in the first derivative. If you plug in 5, for instance, you get 60 times 13, that's positive. If you plugged in 20, you know that's going to be negative. If you plug in 20 times a positive is negative. So you can verify it's a max, but you pretty much know that it's going to be that when you get there. So 18 was x. So that means the box is x by y. So just make sure you answer the right dimensions. So 4 times 18, 72, 108 minus 32, that's so 36, 18, 18. And then the question is basically the same for number 34, only you're reworking the problem for a cylindrical package. So the difference with 34 is that when you talk about the perimeter plus the length, it's a terrible cylinder. So the perimeter this time, if this is our x, the perimeter is a circle. So we can write our girth is now a circle. So x times pi times diameter, and pi x if you want to write it that way, plus y equals 108. So everything else is the same. Solve for y, 108 minus pi x write a formula for volume. Volume equals pi r squared times the height. Area of the base times the height. Plug that in for your value. Take the derivative, set it equals 0.